All right, we're in section 3.2 where we're going to use parallel lines and transversals. So we talked a little bit about transversals in 3.1 where we said it was a line that intersected two or more lines that were on the same plane. So what we're going to look at in this section is if the two lines that the transversal is intersecting, those two lines so happen to be parallel, then those angle relationships that we talked about in 3.1, some of them are going to be congruent. So if you look at this first one here, we have this corresponding angles postulate. So when the two lines are cut by a transversal, corresponding angles are congruent. So they have right here with 1 and 2, those angles, since A and B are parallel, those corresponding angles are congruent. Also, when you look at alternating interior angles, those angles are congruent. And also with alternating exterior angles. The only angle relationship that's not congruent are consecutive interior angles. But since they're not congruent, we have something else that they are. Those two angles are supplementary. Other things that we can also take a look at when these transversals are set, we also notice that we also have vertical angles here and here. We also have linear pairs here and there. So these are things that we can be mindful of when we are solving problems and trying to find unknown angle measures. Okay, so we did this in 3.1, but we can do it again here. They want us to find all of the corresponding angles. So like here, 1 and 5 are corresponding because they're top left. So angle 1, angle 5. Angles 2 and 6 correspond. Angles 4 and 8. And angles 3 and angle 7. So those are the four corresponding angles. So us knowing that, we can look at here, they're saying that they want us to use that postulate to help us find the measurements of the other angles, knowing that the measurement of angle 3 is 125. Well, I can say that through corresponding angles, I can say that, well, the measurement of angle 7 is 125 degrees. All right. Also from here, I know that the measurement of angle 1 is going to be also 125 degrees. I could have used alternating exterior angles. I could also use vertical angles as that. And then knowing that angle 1's 125, 1 and 5 correspond, so that is 125 degrees. So to find the rest of them, so there are what, 4? So we could say that the measurement of angle 2, the measurement of angle 4, measurement of angle 6, and the measurement of angle 8. So all of these things, so like let's say we used 3 and 6, we know that they're supplementary. So supplementary angle means you're just going to take 180 and subtract it by 125, and that's going to get us 55 degrees. And then since we can use that to help us out, so 2 and 6 correspond, so I can say that that's 55 degrees. 2 and 4 are vertical angles, that's 55 degrees, and then 4 and 8 are correspond, and those are 55 degrees. So basically, when two lines are parallel, you have a transversal, essentially all 8 of those angles are just going to be one of two measurements. Looking at these two transversals, both of them are the two lines are parallel from the transversal. I noticed that it has 113 degrees for an angle and 3x minus 4 for another angle. Those two angles are alternating exterior angles. Since they're alternating exterior angles, they are going to be equal to each other. So I can say that 3x minus 4 is going to be equal to 113. Add 4 to both sides. So now I got 3x is equal to 117. Divide everything by 3. X is going to equal 39 degrees. All they want us to do is find x. We figured it out. Looking at these two here, they're on the same side. They're on the inside, so they're interior. That means they are consecutive interior angles. Anytime we're dealing with consecutive interior angles, those two angles are supplementary, so they add up to 180. So if I add them together, x plus 5 plus 3x minus 7, their results are going to be 180 degrees. Combining like terms for the variable gives me 4x. Combining for the constants gives me minus 2. That equals 180. Add 2 to both sides. Now I got 4x equals 182. Divide everything by 4. X is going to equal 45.5. Okay. All right, this problem here, it says a taxiway is being constructed that intersects two parallel runways at an airport. Do you know what the measure, it says, you know that the measurement of angle 2 is 98 degrees. What is the measurement of angle 1? How do you know this? All right, I know that the measurement of angle 1 is also going to be 98 degrees, and because I know this, since the runways are parallel, and angles 1 and angles 2 in this case are alternating interior angles. It says, what is the measurement of angle 3 and how do you know this? The measurement of angle 3 is going to be essentially 180 subtracted by 98, which is going to equal 82 degrees. And uh, since they are in fact parallel, or actually what I can say is this, these two make up a linear pair. Okay. So for these two examples, they want you to identify the type of angle relationship that is shown and then solve for x. So looking at this one here, looks like bottom right. These are corresponding. And since they're corresponding, I can set them equal to each other. 4x is equal to 48, and that means x equals 12. Over here, these are alternating interior angles. And since they're alternating interior angles, I can set those equal to each other as well. Add, what, 2, so 10x equals 100, x equals 10. On the bottom here, it appears that they are alternating interior angles as well, so they can be set equal to each other. And divide everything, so I got 60 divided by 12, so that gives me x equals 5. Over here, I have I got my parallel line here. I got top right, top right. Well, that is when were there neither there's so that's top right. My top right would be right there. So there is no relationship, that's none. But we can still find the value for x. I know that we have a linear pair here and here. So I could take 180 and subtract it 135, which will get me 45 right here. And now I have corresponding angles with that. So now I can say that 4x minus 3 is equal to 45. And then I got 4x is equal to 48. 48 divided by 4 is x equals 12. Last page here. What I have between 7x plus 3 and 115, those are alternating exterior angles. So I could set those equal to each other. So now I got 7x equals 118. 118 divided by 7 is about 16.86, we'll call it. Over here, this is top right, but this is not top right. This is bottom right. So this one's no relation or none. But we can still find x. We can say that, oh, we got a linear pair here, and say 180 minus 103 equals 77. And then we can take 14x plus 7 equals 77. Subtracting 7, so now I got 14x equals 70. 70 divided by 14 equals 5. Two more examples below. Looking at these two, right now there's, well, looking at this one right here. This one's bottom left, that one's top left. Doesn't appear to be any relation, so I'm going to say none. But what we can do is, oh, this is a linear pair for right here. Or actually, let's do it this way. Since it's a variable, I can say that this is also going to be 5x plus 2 because of vertical angles. And these are consecutive angles, so now I can say that 5x plus 2 plus 53 will then equal 180 degrees. So I can take 5x plus 55 equals 180, subtracting 55 to both sides, and I got 5x is equal to 125, dividing everything by 5, x equals 25. And then finally over here, looks like we have alternating interior angles, and they can be set equal to each other, like so. 140 subtracted by 4 gives me 136. Divide everything by 2. X equals 68. And that is being able to use parallel lines and transversals. Hope this helps. Till next time.